All right, so I've received a few comments, notably one from Ed Yu on the channel, where he was asking outright sort of what would you lose going to Odin versus just using Zig, for example, right? And so I wanted to make a video about the differences that I see between these two. And I want to say at the top of this video that fundamentally the differences are not very large. If you're already using Odin and you're fairly comfortable with Odin, I don't think that it would take almost any time getting comfortable with Zig. There are a few pain points that I would say that this would be annoying for sure, right? Likewise, if you're coming from Zig and you're going to Odin, I would say that there are a few key pain points that you might actually feel like, wow, I do want this thing. But overall, the experience is not going to be remarkably worse or better, right? So we're going to go over a few of these, and I guess I should handle maybe one thing at the top. I don't currently have any remarkably interesting uses for comp time. So for those who might not know, comp time is compile time logic that executes at compile time with normal Zig code in order to, for example, calculate types and so on. The most common usage of this we're going to see in this video, but generally speaking, I would say I don't have any interesting uses of this. Certainly none that can't be covered by Odin facilities, right? So comp time is not necessarily going to come into it in this video, but keep in mind if you're using comp time a lot, you may actually not be able to use Odin for those things. One use case, for example, would be if you have a function that takes different functions to construct an interface, right? This is very close to what you in OCaml would call a functor, except we're just passing the functions to it, or we can pass an entire interface. In effect, what we are doing is we're creating a new structure of functions that is parameterized on another structure of functions, right? This is something you can do with comp time, and it can actually be done entirely at compile time, which means we don't have to use any kind of function pointers or anything interesting like this. That is a distinct upside of using comp time. I have that in one project, but I don't think it's super relevant now because Zig has changed so much that I would probably have to fix the code for that project. So we're not going to look at that. The example we're actually going to look at is this here. This is a very simple tokenizer structure with associated functions. So one thing that should be obvious here, if you're a Zig aficionado, is we don't use methods, right? We don't have methods in Odin. So we don't say that there's a function here that is called create, etc., right? We simply say tokenizer create. And of course, this is just a convention. You can call this create tokenizer. You can call it create thingamajig if you want. So here, this would not really, this doesn't necessarily make a difference. The reason you might use this type of convention is that now we can write tokenizer underscore and get suggestions for everything that has to do with the tokenizer. So that is useful. And then, so we have this tokenizer structure here. If we look at the corresponding thing in Zig, let's see here. So we have tokenizer. Let's see here. If I could find this. Token iterator is what I have called this in the Zig version. Sorry about that. They are the same thing, basically. They serve the same purpose. So again, in Zig we have methods, right? these methods, this is just a function that lives in the namespace token iterator. This here is a method. The difference being this takes a self pointer as the first argument, right? So this is passed implicitly. So effectively it gives us method syntax for just functions that are associated with some kind of type, right? Also we can see here in the init function, right? This is of course our create, right? Create here is a little bit less chatty, right? So we can see here init, it takes a bunch of arguments, or 2 arguments, right? It returns a self, which is an alias to whatever struct we are currently in. And then we return, oh, the file name is the file name, the buffer is the buffer, I is 0, line is 1, column is 1, for example, right? Whereas in the tokenizer here, we can see that we have the majority of these things, right? However, what actually happens here is we don't set any of those values, right? And that's interesting, right? Because this is a general kind of theme in some sense between the 2 languages, I feel. There are certain things in Odin that are made, in some sense, they are made to not be unclear, right? But that does not imply verbosity necessarily in certain cases. So one of these, of course, is 0 value initialization. When we create the tokenizer here, any value that is not set to something specifically will just be implied to be 0 value, right? That means that all of these ones, right, index position, column, and so on, the file name here, they are just going to be 0 value, right? And so these values can be filled in at some other point, right, where they are actually needed, for example. Of course, this implies also, or this means that we can fail to set them, right, and get unexpected behavior, right? I did not say undefined behavior, could be get unexpected behavior, because we might have, for example, a bug because we're not setting this value. Maybe we forgot, right? And that is entirely a possibility, right? But also, if you simply choose to do so, right, you can simply not set these values and it's fine. Odin does not care. Whereas, of course, if in this particular case, I here, it's almost an internal kind of internal value. It doesn't matter necessarily. We don't necessarily want to set this value, to be honest. And we shouldn't really have to be honest, right? So we could just solve this in Zig actually by saying this is 0 here, right? And we might, right? But then we basically have to add stuff here. Whereas the assumption in Odin is simply everything is 0 value initialized. And of course, the 0 value is special in Odin in many, many different cases. So it's not that Odin picked exactly this particular situation and said, oh, no, we shouldn't have to mention this, and that's that. No, the 0 value is, of course, special in Odin for error handling, for or else, and so on, right? So it makes sense that the 0 value would be, it would have a special position in the language and so on. And we rely on that 0 value. We always handle that 0 value. It should have a meaning, for example, right? This is not necessarily the case in Zig. Zig does not have the same relationship with 0 values as Odin does, right? They have not blessed the 0 value in any way, right? Whereas in Odin, of course, it just matters a lot more, right? And you can actually make mistakes with it as well by not setting it and so on. So we've covered, we don't have methods in Odin. We have instead functions that operate on a thing, right? We don't have to set all the values, and they are just assumed to be 0 value instead, right? Let's see here. Right, let's look at expect here. And I'm going to look at the Odin example first, because I think it is a little bit maybe what one would expect. No pun intended. So in this function, the purpose of this function is to use the tokenizer structure, the token iterator, to just ask for the next token, right? And when we get the next token, compare it to some kind of expectation, right? And if that expectation is not met, we have a expectation failure of some sort, an expectation error, if you will, right? In Odin, this looks as follows. We ask for the next token. We check what type that is. We compare it to our expectation. We then say, if that doesn't match, we want to say, we have an expected token error, right? And we add our expectation, what we actually got, and then a location, right? And this is useful, of course, because if you write a parser for something on top of this tokenizer, now you can just report, I was unable to parse here because I expected a symbol. We actually found a number, for example, right? An integer, perhaps, right? And this is fairly straightforward. I think this is what we would expect, generally speaking. We would expect here to return an error that has information attached to it, right? But unfortunately, and keep in mind, I have not paid attention to, for example, because there's always, as long as I've used Zig pretty much, I think, it maybe showed up a little bit later, there's always been an issue in the issue tracker for attaching, basically using unions instead of just error sets for errors. So let me give you some context on that, right? Zig is of course known for its error handling. This bang here basically says this function can return an error. And when we only have bang here, it means we are inferring that error. If we had some kind of error here, an error set here, we could actually say only these specific errors are allowed. But generally speaking, what you will do in most code is you will infer the error set. This means every call that is made in this function is going to be analyzed for which errors it can return. One problem though is that all of these errors are simply codes. They are basically just numbers, right? They are numbers managed entirely by Zig, right? But they are numbers nonetheless. It's a set of errors, error codes, right? They don't contain any values, but we know we want to report errors in this code. So what do we do? Well, the solution is fairly simple. We have this expect error pointer here. An expect error can be one of two things. It can be a token or a one-of, right? So that would indicate we are expecting this here, we're expecting this other thing here, and so on. When we do have an error, right? So here you can see if the active tag and the expected token match, we just return the token. We're done. Otherwise, we're going to set this expect error here to a certain error, right? And then we're going to return unexpected token. And when the caller sees unexpected token, they will know, I have to check the expect error, right? But this is a little bit a roundabout way of doing things, right? It doesn't 100%, it doesn't feel particularly great, right? The obvious thing that I would want here is simply say, expect error here, right? Or expect error in everything else, right? The real solution I want is for this bang to indicate, oh, this is a union of errors, right? There's a union set, you could call it, right? But that's not what we have in Zig. And this is it's certainly not a breaking kind of thing. If you have a project and you have to do this, I'm pretty sure you're going to be fine. This was one of my first kind of, let's say, mid-sized projects or whatever you want to call it. It was a real project. This was part of a type compiler, transpiler, some people would call it, that basically takes a source language that looks suspiciously like Zig and writes out type definitions and validation functions for different languages. So in the Zig version, it was originally TypeScript and F#. These were the two languages that I chose. F# because it has honestly really nice decoding libraries and so on. And you basically write functions for decoding JSON and so on. And this is the purpose of all of that, is to make basically write definitions in one file, export it to different languages, and these languages can now talk amongst each other because they all have the same type definitions and so on. So if you write one service in one language, you can have the other service actually understand these types because they all happen in the same compile step. But yeah, this project was completely fine despite this, right? But I have to admit, it is now hard to look at this and say, oh yes, I will exchange this, right? This code here, I will take that and just make that this. This is, it's a fairly small difference, to be clear, right? But it is the largest one that I personally see between Odin and Zig. Apart from that, they both serve exactly the same purpose to me. They are both extremely simple languages. You can learn them in almost no time at all. I tend to call these weekend languages. That's not necessarily, you know, if it takes you longer than a weekend to get comfortable in Odin, I absolutely 100% understand. That's not what I mean, right? But potentially for someone who has some experience in some of these things before, it certainly does not take a very long time in comparison to other languages, right? And so they are both that type of language. I like them a lot, right? Both of them. So I don't mean here to make some massive difference between these. But yeah, these are basically the differences that I see between these languages, right? Odin overall, because of, you know, certain ideas, is a little bit less chatty, like this here, right? And if we look at another aspect of this, right? When we have allocators in Zig, the general kind of behavior here is to just have them as arguments, right? And of course you could try to have default arguments, but we don't have context in Zig, right? So if we look at the Odin version, in Zig here, we would have to just take some kind of argument here. It might have a default value or something, right? But in Odin, what we can actually do is we could just say context.allocator, and then we could say runtime default allocator, whatever. It doesn't matter here so much what we type, right? This is some kind of allocator. And for this entire test here, I'm going to just be using that, right? And I know that for sure, right? Likewise, we can get the best of both worlds if we just say, hey, I have a procedure that allocates like this. We have some kind of allocator, context.allocator, right, like this. This is a proc, of course, right? And this function now is basically the kind of middle ground here, right? We have an argument, we can override this, right? But by default, it just takes whatever the context is. This means in tests, we can say, or wherever we want, we can say, oh yeah, in this particular case, I don't care, right? It is just going to be what's in the context. But in this other case, I might say, for example, allocator is equal to my cool new allocator, right? Or buffer allocator only has 2 megs. What a loser, right? So I might actually pass that as the allocator instead. And that's fine, right? We get the best of both worlds here because we can actually be implicit, right? So in some sense, Odin allows for code to be more implicit sometimes. And of course, this is a design choice that Zig has made. I'm not at all saying it's by accident that Zig is more explicit about things. No, absolutely 100% they are. That's the code they want. And that has value, right? Certainly it has value over a long period of time. Explicit code is oftentimes easier to understand, but I think that there's a key to the implicit things that Odin allows that makes it much easier to deal with, right, than certain other cases of implicitness, for example. We know the implicitness of these structures and not having to set the values comes from the fact that everything is 0 value initialized, always, right? That is a very strong thing, right? We can rely on that, right? We write our programs around that is everywhere. So that kind of implicitness does not have the same cost as just, other kinds of implicitness, right? We know also we have a context. This cannot go wrong here, right? Of course, we could forget to set an allocator for a certain scope, right? That could happen. Absolutely could, right? And I think all of this is to say that I think that there are certain things that Odin is much more comfortable with being implicit about, right? And code written in Odin will tend more towards that when it sort of can, right? So I think in terms of the usage of the two languages, there might be a few slight differences there that can feel slightly uncomfortable, right? Related to that would also be, for example, that Zig is much more expression-based than Odin, right? So if we look, I don't know if I have this in this particular, oh yeah, here. This is a good example. Switch, the switch statement is not really a statement in Zig, right? It's a switch expression, right? And so here, this entire switch will return a value. That's why we can say here that it returns a token, right? And so this, of course, in Odin does not necessarily make a lot of sense. Most constructs in Odin are statements, right? Like this. You can have, of course, an if expression. You can have a ternary expression that returns, it's basically an if that returns a value, right? But we tend instead more towards, you know, imperative procedural code that just sort of, it's more about setting values in these different branches and so on, right? Whereas Zig is a little bit more, I don't necessarily want to use the word modern here, right? But, you know, more towards expressions over statements, right? And that can also factor in, right? It can make a language feel either good or bad, right? So I remember the first time I used dlang, this was a while ago. I don't know that Zig existed yet. But I had been using expression-based languages for quite some time at that point. And I found overwhelmingly that at least the constructs I was using in D that sort of seemed most obvious to me, they were not expression-based. And it made it feel a little bit off, right? Of course, you'll note that now I'm, you know, obviously very comfortable with Odin, so that all kind of wore off at some points, right? But this is one of the aspects that you can certainly like about Zig. Right? It is more expression-based. There's more, let's say, let's call it C-style usage in Odin, where, no, the majority of things are, you know, statements. Certainly all of the control flow stuff is just statements and so on. And we treat them as such, right? And in Zig, you don't really have to. A lot of them are just expressions. They will return values and so on. And this can be, you know, this can fit a lot more with how you think, for example, right? And so, yeah, I may have forgotten things here that I wanted to mention. I may have left things out and so on. I think the main takeaway here is that I think error handling is a little bit straightforward in Odin. We don't have to set up these extra variables here like this. You know, we don't have to have an expect error that only is filled in, and you know, if certain conditions are met and so on. Instead, we get this. We can just, you know, actually return the context instead, the actual error value. Right? All of the context for understanding that error is in the actual error instead, right? So that is the main difference to me, certainly. The rest is sort of fairly minor stuff that I believe you can certainly, you don't have to change much about how you view things in order to get around them. It is maybe mostly kind of pedantic stuff, I would say. And also the toolchain is very nice in Zig. I do think that they've done a great job with this, right? But yeah, I hope that this was, you know, just to stave off possible, you know, this is in no way intended to be flame bait or whatever, right? These are my honest views on these two. I hope I was fair. I certainly wanted to be. I certainly tried to be. And the truth is, like I said, I wouldn't mind using either of these languages. It's just that I slightly prefer Odin. That is really it. I think that they're both fantastic. They're both certainly the two best languages that I have had the pleasure to even know of in this entire space of sort of new lower level languages. And I think it's better that they both exist no matter what, right? They both have already made a mark, certainly Zig more so than Odin. And I think we would have better software if everyone just chose either of these two, if I'm being honest. That's my flame bait. So everyone else, so now I've probably pissed off people who don't like either of these, yeah, have fun. No, but yeah, so these are my views on these two languages, and I hope this was kind of a useful view on practical, considerations here with regards to the features of the languages, what they emphasize, and so on. And have a nice day, and ciao. I want to thank everyone who has watched this video, but especially our channel patrons, Jeff Ward, Matthew Cruz, who are Hex08 members, Ed Yu and Znania, who are Hex04 members, and Dmitro Sereda and Mikhail Dobrev, who are Hex02 members. Thank you so much for supporting the channel. Your support means everything to me. Ciao, and have a nice day.